So rule number one, right, is any number that only contains non-zero numbers. So if we had 1, 2, 3, 4, that's a pretty easy one, right? You count everything. So that's 4 sig figs. 1, 2, 3, 4. And just to avoid any confusion, some people get confused because some people say significant digits, some people say significant figures. It means the same thing. Okay, I say sig figs. Rule number 2, captive zeros. So if we took this same number, right, and threw some zeros in the middle, those zeros, if they fall between two non-zero numbers, count as significant digits. So again, in this number, we would count everything. 1, 2, 3, 4, 5, 6. 6 sig figs. Okay, number 3, so the leftmost zeros in front of non-zero numbers, so it would look like this. Right? These zeros here simply act as placeholders, so they don't count as significant. All right, so what you do is you start counting right here. So 1, 2, 3, 4, 4 sig figs. Right, so those zeros are not part of the measurement itself. They're simply there acting as placeholders. All right, so if we had these rightmost zeros, right, that come after a decimal point, those zeros are there because someone took a piece of scientific equipment, right, and made sure that that measurement fell right on the 0, 0 line. So those zeros are actually part of the measurement. It took extra effort to put them there to let someone know that they are in fact significant and part of the measurement. So those do count as significant. All right, so in this number we have 1, 2, 3, 4, 5, 6. Does this all sound familiar? You should have seen it in Chem. If you took physics, you probably saw it. Do you guys just, I don't think they do this in bio. All right, so if we kind of took the same exact number, but we did not include a decimal point, so let's say we had this, then these zeros end up being just like those zeros. They're just placeholders. Okay, so without the decimal point, those rightmost zeros do not count as significant. So this number has 4 sig figs. Oh. Okay. But if you don't want to remember all those rules, I kind of have a trick for doing sig figs. So So let's pretend that looks like a picture of the United States, right? Got Florida, kinda. Texas. I don't know what that is. Washington, Maine. Right? Just pretend. I'm not an artist. And then what's this big body of water out here? The Atlantic Ocean. All right. And then what about this big body of water out here? Pacific. Some people don't know, but it's fine. Okay. So when we're talking about sig figs, right? Sometimes the decimal point is absent, right? Sometimes there's no decimal point. And sometimes the decimal point is present. Sometimes it's there, okay? So what does that have to do with the United States? Well, let's see. So let's take a few numbers where our decimal point is in fact present. Okay. So if the decimal point's present, right? You're gonna look at the number. You're gonna put your hand like this, and you're gonna come in like it's a little boat, right? Remember, I was a little more cheesy last year when they were sophomores, but I won't be that way with you guys. But if you come in from the Pacific Ocean, coming this way, and you stop at the first non-zero number, which is the 1, then you count everything. So 1, 2, 3, 4. 4 sig figs. All right. So let's try it with the second number. Again, decimal point's present, so we're coming in from the Pacific Ocean, the little boat, like Hurricane Dorian, but they don't come from this side. Right, we're gonna stop at the first non-zero number. What is it? The 1. We're gonna count going this way. 1, 2, 3. 3 sig figs. And it works every time. It's better than memorizing rules, okay? Now, if the decimal point is absent, let's see. Right? This time, you're going to use this hand, and you're going to come in from the Atlantic Ocean. And again, you're going to stop at the first non-zero number going that way. So if we're going to do 21,000, we're going to come in this way, stop at the first non-zero, and count going that way. So 1, 2. 2 sig figs. Okay. Try it with this number, right? Atlantic Ocean. Stop at the first non-zero, count 1, 2, 3, 4. It's a lot easier than the rules. Does it make sense? Okay. So, sig figs. One more thing. What about when we have a number in scientific notation? Anyone remember the rule for that?
Oh, I forget the exact name, but whatever the 4 about 20 is one of the digits over is the same.
Right, so this part of a number in scientific notation, what's that called? Anyone remember? Starts with a C. Might hear it in algebra. Not a constant. Sometimes it's the number before a variable. Coefficient, right? So this is the coefficient in scientific notation. So if you want to figure out how many sig figs are in a number in scientific notation, right? All you look at is that coefficient and you count everything in it. So this number would have 3 sig figs. Even if it was something like this. Right, take that coefficient, count everything, 1, 2, 3, 4, 5, 6, 7, 8.
If I count everything, do you mean like the rules will count? Just everything or just count everything?
Well, technically the rules,
Well, for there, yeah, for there it works. So like if there's 150.
if the number is in proper scientific notation, the rules will count. And I wouldn't give you something that's in improper scientific notation. Oh, you don't have to be sorry. You can ask questions. And then one other thing, right? So when we start doing our calculations and you have to put a number in to proper sig figs, let's say we did a calculation and we got this number. So let's say express in 3 sig figs. I'm just trying to think of everything that could possibly come up that would cause a question. So let's say we had 300,000. And we had to express that in 3 significant digits. Any ideas on that?
Put it in scientific notation.
You would put it in scientific notation, that's right. Right, so you would just go 3, 5, so 3.00 to get my 3 sig figs times 10 to the 5th. Okay, so if you're trying to get a number into the correct number of sig figs and you're struggling to do it, just go ahead and put it right into scientific notation. It's the easiest to do. Okay, so let me give you guys a little practice. Oh, actually, let's do multiplication and division first. So there's a different rule for addition and subtraction. So we'll start with multiplication and division because it kind of meshes with this a little bit better. What you do is the numbers that you're multiplying or dividing, you count the number of sig figs in each of those numbers, and then you're going to round your answer to the least number. And we'll do a few examples together. So round answer. Alright, so do me a favor. Figure out how many sig figs are in each of those numbers. Alright, so how many here? How many here? It's easy when there's no zeros, right? So what we're going to do is we're going to do the math. And then we're going to round to how many sig figs? Alright. So this is what I get. And we're going to round that to 2 sig figs. So you have two options, right? You can take this 0 and leave that at 0, and you can just write 90 with the decimal point. Or you can put it in scientific notation. Times 10 to the 1. There it is. All right. How many sig figs here? 4. How many here? 2. So we're going to round our answer to 2. God bless you, whoever sneezed. Okay, so I get this number. And this is a good, they're giving us good, tricky examples. How fun. All right, how do you think we're going to round that to 2 sig figs? Because the 9 will round this up, right? Which rounds this up. So what's that going to look like in 2 sig figs? 4.0.